Alright, welcome back and Assalamualaikum everyone. So for today's class, we are going to proceed on the next part of cluster analysis. This is the second part, yeah. So previously, in part 1, we have seen the basic concept of cluster analysis, right? And then the clustering structures, and we know that there are two types of clustering that are partitioning methods, and also we have the hierarchical methods. So for today's class, we are going to see what is hierarchical clustering all about. Okay, so hierarchical clustering produce a set of nested clusters organized as a hierarchical tree, and this hierarchical tree can be visualized as a dendrogram here. What is dendrogram? Dendrogram is a tree-like diagram that records the sequence of mergers or split between the clusters. Okay, so let's say we have some points here. So you can imagine all of these points, 1, 2, 3, 4, 5, 6 points here, right? And then we know that in previous slide, there are two type of clustering, right? Partitional clustering, where it is a non-overlapping subset or non-overlapping clusters. Now, in hierarchical clustering, it is a set of nested clusters, right? So what is nested clusters? Meaning that the clusters are overlapping to each other, and the overlapping will be represented by using the hierarchical tree or dendrogram here. Okay. So from these clusters, we can see the overlapping using this dendrogram. So from this dendrogram, we can see here these are the points. Okay. These are the points representing the object. And when I say the object, meaning that this is the row in your database, okay, in your dataset lah. Okay, and then this one, these are the distance. Okay, distance between the point, or we can say that this is the dissimilarity matrix that we are going to calculate here. Okay. So in hierarchical clustering, it uses distance matrix as clustering criteria. This method does not require the number of clusters K as an input, but it needs a termination condition. There are two strategies of hierarchical clustering that are agglomerative and also divisive. So usually we are going to use agglomerative. In this chapter or in this slide, we are going to discuss on AGNES here, okay, where it is a bottom-up strategy from step 0 to step 4. From a single point of object, it will be clustered into what they call that a big cluster. Okay, so this is what we call as the bottom-up strategy. So from here, you can say that you can see here A and B will be clustered together, and then D and E will be clustered together here, and then the cluster of D and E will be clustered with point C here to be a new cluster, that is CDE, and these will be overlapping, yeah. And then these one clusters, AB clusters, will be clustered with CDE cluster to be a big cluster here. So this is the biggest cluster. Okay. In hierarchical clustering, okay, you know that there are two main types of hierarchical clustering, that is agglomerative and divisive. So in agglomerative, it starts with the point as an individual cluster. So we can see that from there A, B, C, D, E, F, right? And then at each step, it will merge the closest pairs of clusters until one cluster. Okay, until one cluster or K cluster left. So we know that this is from here, this is the biggest cluster. So this is the one cluster. Okay. What about divisive? So in divisive, it will start with one all-inclusive clusters. Then at each step, it will split So this is why we say this as top-down strategy. So it will do the splitting. In bottom-up, we will do the merging. Okay. At each step, split a cluster until each cluster contains a point, or there are k clusters. Okay. So traditional hierarchical algorithm use similarity or distance matrix to do the merging or splitting one cluster at a time. Okay. So this is agglomerative, so you may read this. So usually it will use a single link method and the dissimilarity matrix. Yeah. Please refer back the previous video or the previous slide on the dissimilarity matrix. I have explained on you what is dissimilarity matrix all about. Okay. And then it will merge nodes that have the least dissimilarity matrix where it has the minimum Euclidean distance. Okay. And then we'll go in a non-descending fashion, and eventually all nodes will belong to the same cluster. So you can see here, so we have 2 clusters, 3 clusters here, and these clusters will be merged into another clusters, and all of them will be eventually belong to the same clusters. In agglomerative clustering algorithm, it is the most popular hierarchical clustering technique, and the basic algorithm is quite straightforward. First, you have to compute the dissimilarity matrix, and then you have to let each data point to be a clusters. And this is the thing that is very important, where you need to repeat these 4 and 5 steps. One, you have to merge the 2 closest clusters. Okay, so you need to have 2 clusters first. Okay, 2 clusters with the lowest Euclidean distance. Okay, or the lowest dissimilarity matrix. And then you have to update the proximity matrix between these 2 clusters. You need to calculate the dissimilarity matrix, and then you need to do the another clustering, the overlapping clustering. So you have to repeat them until you only have a single cluster remains. Okay. The key operation is the computation of the proximity of 2 clusters, and different approach to defining the distance between clusters distinguish the different algorithm. So how are we going to define this intercluster similarity or this distance here? Okay, so we can use minimum. Okay, we can use maximum distance. Okay, we can use group average and also distance between centroids, and other method driven by an objective function. For example, Watt's method uses square errors. Okay, so usually we are going to use a minimum and maximum distance. Okay, from here, if we take a look at minimum, so we have 2 clusters here. So this is cluster number 1, and this is cluster number 2. We are going to find the minimum value of the proximity matrix. If we need to find another way that we use a max, so from cluster 1 and cluster 2, we are going to find the maximum proximity matrix between these 2 clusters. Group average, distance between centroids, and Watt's method will not be covered in this chapter. So in cluster similarity, okay, you have 2 types, right? Previously, you have minimum and you have maximum. So in minimum is actually a single link. Maximum is called complete link. In minimum, it is a similarity of 2 clusters. Okay, 2 clusters. Please remember, it is a similarity of 2 clusters, not 2 points. Because if we calculate the similarity or dissimilarity of 2 points, okay, we are going to use the previous method that is using the Euclidean distance. Okay, this in minimum, it is a similarity of 2 clusters is based on the 2 most similar. or we say that the two most closest point in a different clusters. So these will be determined by one pair of point. In example, one link in the dissimilarity graph. Okay, so this is the minimum or single link. So when we talk about this statement here, determined by one pair of points, in example, one link in the dissimilarity graph, okay. So meaning that from these two clusters, okay, we are going to determine, okay, the distance between each point here, okay. For example, we say that we have cluster of 3, 6 and 2, 5, right? So we are going to find the distance between each pair of point. For example, 3 with 2, okay, pair of 3 with 2, and then distance of 6 with 2, and distance of 3 with 5, and also distance with 6 and 5. So from these pairs, we are going to find the minimum distance from all of these pairs. Okay, so that is why we have here the example here. We have distance of two clusters. Cluster 1 is 3, 6, and cluster 2 is 2, 5. And we are going to find the minimum distance from these pairs of the clusters. Okay, so distance of 3, 2 will be given, and distance of 6, 2 will be given, or you have to calculate it first. Okay, distance of 3, 5, okay, and distance of 6, 5. Okay, so logically you can see here that 3, 2 is the lowest, right, from this image here. Okay, but then if we calculate it, or we have the exact number of it, we say that distance 3, 2, okay, based on our calculation of distance using equilibrium distance, 3, 2 is 0.15, distance of 6, 2 is 0.25, distance of 3, 5, okay, 3, 5 is 0.25, sorry, 0.28, and distance of 6, 5 is 0.39. We know that this is the farthest, right? I mean, this is the most far from other points, okay? So we know that when we say that we want a minimum point, it will be distance of 3, 2 here. That will be 0.5. So the distance between these two clusters is 0.15, okay? What if we use maximum or complete linkages as how to determine the intercluster similarity, okay? So when we say that we use maximum, meaning that we have the similarity of two clusters is based on the two least similar, or the two most distant points in different clusters. So we determine all pairs of points in the two clusters, okay? And then from this, it goes similar to minimum operator, but then it use maximum. Okay, maximum operator. From all of this, okay, we can say that 0.39 is the most distant point in your clusters.